young lady was trying to play tug of war with me. She has a lot of force. She's really strong. Whew. Today, we're going to talk about balanced, so things are balanced, and unbalanced forces. So, to start us out, let's just do a recall. What is a force? A force is remember my song, a push or a pull, a push or a pull. Remember, with a push or a pull, we have a force acted upon an object. And remember that forces can also change the shape of something sometimes too. Take your Play-Doh, for instance. Think about how hard a 3-year-old could push it down, and how hard an 8-year-old or a 9-year-old like you could push it down. Yeah, get that Play-Doh. A little different force. Okay, so what makes it balanced? What makes it unbalanced? So we're actually in lesson 2, and if you numbered your packet yesterday like I asked you to, lesson 2 should start on page 13. Lesson 2 should start on page 13. And we're not going to do a whole lot in this packet today, but I do want you to just look at the picture on page 14 on the big idea for today, which is balanced and unbalanced forces. First, we have to think about who's going to win that tug of war, that first picture. Who's going to win? Those arrows show you that the forces are pulling away from each other. So who's going to win, do you think, if they're both pulling away from each other? And then the difference with the bottom picture is we have to draw the arrows, of course, for the forces. So they're pulling back. So we would draw the arrow going that way again. And this guy's pulling back. So you draw the arrow going this way. But who's going to win? Okay. And then let's think about why. So pause the video for a second. And actually, you can just circle which one you think is going to win in the first instance and in the second instance. So just circle those. Pause. You're back. Okay, great. So hopefully you realized that this first picture, the forces are acting upon each other. So it might be a tie depending on the strength of those people. Now this one, there's 2 men and there's 1 person over here. So you probably guessed these 2 guys are going to win. But it's not just because 2 people against 1. What if you were playing tug of war with a 2-year-old? 2 2-year-olds. You against 2 2-year-olds. Who would win then? Not the 2 2-year-olds. Please don't do that and hurt 2-year-olds. But anyway, so the first picture shows the game of tug of war, and they're both, like I said, pulling on the ropes. And I'm on the next page just kind of glancing at that a little bit too. So as you can see, the arrows are pointing opposite ways. And the men that are pulling opposite ways are about the same size. Okay, so you have an equal force acting upon itself, equal force, pulling in an opposite direction. So you can probably assume that no one would win. It would be a tie. It would be, they would call it. So because they remained in the same place. But anyway, this smart fellow named Isaac Newton described in his first law of motion that we learned in lesson 1, if the forces are balanced, then an object will remain at rest. So you're pushing and I'm pushing against you. We're just going to probably remain there. You could try back to back with a family member and see who pushes and who. You're probably not going to move a whole lot unless it's your dad against you or your mom against you. But if you have a pretty even sized person, your backs are against each other, try it, and you're pushing and he's pushing and you're pushing and he's pushing, you're probably not going to move a whole lot because the forces are balanced. Okay, and then like I said in the second picture, the 2 guys are not going to win just because they're 2 guys. They're all equal sizes. So when you have 2 equal sizes acting upon one All three of those people are equal sizes, so the two are definitely going to be stronger than the one, because there's an unbalanced force because there's only one against two. So therefore, the two guys would win because the force is stronger. And so again, it's not just because there's two against one, it's the adults. They're all adults and they're all pushing in an equal force against each other. Only one has a little more power than the other. Okay, so what you're going to be thinking about today, we can't play tug of war. One, it's COVID. Two, I can't pull against you through the computer, unfortunately, but this page you can cross off or play with a friend if you ever get the chance. So that brings us to be talking and practicing balanced and unbalanced forces. So you're going to be watching another little video, and then I'm going to share my screen, and you're going to be working just to think, because as scientists, we need to make observations and make scientific thoughts of what we have learned. So let me share my screen. All right, loves. So you can see this assignment that you will have. It's called Balanced and Unbalanced Forces. This little video is super good. And to guarantee that you watch it, I'm probably going to stay on recording while you watch it with me, and then you can always watch it again. Then after we watch the movie, or after you watch the movie, you're going to drag and sort these. So for example, this green one, a train moving at a constant speed. So they're not slowing and going faster and slowing and going faster. Would that be a balanced force or an unbalanced force? And I think this will be a little clearer once you watch the movie. A skier coming down a mountain. Pretty big force going down a mountain. Okay. A parachuter falling to the ground. A car accelerating, so going faster at a starting line. So like a race with cars. An apple hanging from a tree. It falls. Maybe, well, it doesn't say it falls, excuse me. An apple hanging from a tree. A soccer ball on the grass. A tennis ball being hit by a bat, and a book sitting on a desk. Okay. So are these examples of balanced or unbalanced forces? I'm not sure yet. So I think to get a better idea, we need to watch the video. So I'm going to share my screen again and the sound. So here we go. Balanced and unbalanced forces, science of forces.
I'm Dr. Jeff Vinegar, and today we'll explore the science behind balanced and unbalanced forces. With Dr. Jeff. Sometimes, when equal forces combine, they can cancel each other out, and we call it balanced forces. The simplest example is a tug of war.
War? I'm out of here.
Okay, guys, grab an end. Perfect. I've tied a flag into the middle of this tug of war rope, and when I say go and blow this whistle, you're each gonna pull it in opposite directions as hard as you can. Ready, set, go.
You're going down, Zoe.
Yeah, well, you're going up. What? What does that even mean?
I don't know. I'm not very good at comebacks, okay?
Nice job. As you can see, the forces were in opposite directions, so they were balanced. But if Zoe pulls as hard as she can while Izzy's not paying attention,
Whoa!
then the forces are no longer balanced and the flag goes that way.
So does Izzy.
When they both pull in opposite directions with equal force, the flag stays right here. Until the forces are no longer balanced. The result? Motion.
Hey kids, if you want to watch this whole episode and more, tell your teacher to sign
And I would, but it's expensive. Okay, so okay, so a train moving at a constant speed. What would that be? Balanced or unbalanced force? So a train moving at a constant speed. Let's see. So you're going to click and drag. So let me give you an example of one that is, oops, can you still hear me? Oh, sorry. I think I paused the video. 1 second. I think I made a little boo-boo. Just a second. Okay, sorry about that. So let me share my screen again. All right, I have an easy way to think about balanced and unbalanced. So as you saw in the video, the kids were not moving when the force was balanced, when they were both pulling with the same amount of force. And so there was no motion. Neither one of them moved. But as soon as one of them, the force was broken, then one moved. Okay, so we're going to think about balanced, not moving, because the forces are acting upon each other. And unbalanced would be things that are moving. I think that would be your easiest way of thinking about this. So for example, a car accelerating at a starting line. So as it accelerates, it is working against the force pushing upon it, which could just be the atmosphere. So that would be unbalanced because it's moving. A soccer ball on the grass, it's not moving. It's just sitting there on the grass. So that would be balanced. Okay, so again, kind of use this as a guide. And this is just for fun and practice. And so again, I'll put a little note on this assignment as well to show you that balanced doesn't move, unbalanced means that it's probably moving. Okay, and then you're going to think like a scientist and answer this question. Who will win the game of tug of war? Explain your answer using scientific reasoning. And you're going to use the word force in your answer, maybe motion. So I'll put that here. Use the words force and motion in your answer. Okay, so boy or girl would win, and because there's more force or because there's less force, and because and so therefore she would win or he would win because they're moving, the motion. Anyway, so at least use the word force. I just kind of blah blah blah. And enjoy this lesson and try to do a little bit of that. Thank you for watching my long video, and I appreciate your time watching this whole thing. Thank you so much. Have a good afternoon.